Okay, this is the QCAA 2021 Maths Methods External Assessment. This is Paper 2, Technology Active. Question 1. The scores obtained on a test can be assumed to be normally distributed with a mean of 102 and a standard deviation of 19. This is a straightforward normal distribution question. I'm going to use the normal CDF function of my TI-84 calculator, and I'm going to type in the lower bound of 113, choose a large number for the upper bound, the standard deviation and mean 102 and 19. If I calculate that, I get 0.28, which is answer A. Okay, question 2. A substance is being heated such that its temperature T in degrees Celsius after T minutes is given by the function T equals 2 e to the 0.5t. So the first integer value for T, for which the instantaneous rate of change of temperature is greater than 100 degrees Celsius per minute, is in this question here, because they're asking for the instantaneous rate of change, I should be thinking derivatives. So that's why I was ready to write here. The derivative is going to be e to the 0.5t. Bring that half down times by 2, just becomes 1. And if I substitute the values in the answers, it's probably the quickest way to go about this. So if I try 10, and that gives me an answer, if I type that on my calculator, 148.41. And yes, that's over 100. Looking for the first integer values, so at this stage it's 10. I could try the next one, which is 9. T equals 9. That gave me on my calculator, I've got 90.02 if I've done that correctly. That means that that's not greater than 100, so that means that the answer is A, 10. Okay, question 3. We've got a random sample of people who are surveyed about the most important factor when deciding where to shop. The results appear in the table. We've got price, quality of merchandise, service, shopping environment. If the sample size was 1,200, the approximate 95% confidence interval for the proportion of people who identified price as the most important factor is A, B, C or D. So I'm going to use the calculator to determine the confidence interval here. For my calculator, it's the stats test, and I think it's A to bring up the one prop Z int, which is the test we use for maths methods confidence intervals. I'm going to type in rather my X value is going to be, well, there's 40% of 1,200. That's how many people were surveyed, and N is 1,200. C, my confidence level is 95, so 0.95. If my calculator calculates that correctly, I get 0.372 and 0.427, which in this case is going to be answer D. Alright, question number 4. We've got, using the trapezoidal rule with interval size of 1, the approximate value of the integral between 0 and 3 of 0.5 to the power of x dx is, in this case here, I'm going to use a slightly different approach, because one of the things that you have to be aware of in the exam is that time is going to be one of the factors you're going to have to consider. You should be allowing about 10 minutes for the multiple choice questions. They're worth 1 mark each, so 10 minutes is about what you need to aim for. So one of the methods I could use in this question, I could use my trapezoidal rule, and I could write the trapezoidal rule out, probably jot all the information down, use my calculator to help me determine the values and type it in a formula. But the other way I could do it, and you don't necessarily need to draw a diagram for this, but I want to just show you what I'm thinking when I look at a question like this. When I've got this is the function here, so you need to realise that it's going to look something like this, half to the power of x. Then I've got, if I'm going to use my trapezoidal rule, I've got these 3 strips here, and I'm going to have a trapezium here, here, and here. So 3 trapeziums. Now, one thing I want to point out is with these 3 trapeziums that hopefully you can see, because of the shape of the curve, I have overestimated here and here, and I didn't really draw that well, but there's a slight overestimation in each of these trapeziums. So using my trapezoidal rule, I'm going to get an answer that's going to be slightly larger, only slightly larger than the exact value. So my cheat in this question is that I'm going to use my calculator to determine the exact area under the curve. So using my integral function on the calculator, I've got 1.26. My area is going to be slightly larger than that, so if I'm looking for a quick way to answer this question, what's an answer that's slightly larger than that? Well, it's not A, it's not B, it's going to be C, which is 1.31. Of course, you can use the trapezoidal rule for this, but I think this way might have saved you a little bit of time. Okay, question 5, we've got the log. Solve for x given the log of base 3 of x minus 1 equals 2. So this is probably one that can be answered very quickly and easily by hand. If I rearrange this, I get 3 squared equals x minus 1. So 9 minus 1 plus 1 equals x, x equals 10, which is answer D. And question 6, we've got when seeds of a certain variety of flower are planted, the probability of each seed germinating is 0.8. If 8 seeds are planted, what's the probability that at least 6 will germinate? So this is a question that involves discrete data, so you should be thinking, I'm going to use my binomial features of my calculator. In this case, my calculator, I'm going to use binom CDF, and the number of trials is 8. My probability of success is 0.8. Now, when you use 5, you might be thinking, well, why am I going to use 5 in this case? Because the question is asking, what's the probability of at least 6? Well, the probability that x is going to be greater than or equal to 6, or at least 6, is going to be the same as doing 1 minus the probability that x is less than or equal to 5. Now, I'm going to do it that way because my calculator doesn't have a calculate to the right type function that I know some of the calculators do. So I'm going to do it this way, and my calculator gives me a value of 0.2, and when I do 1 minus that number, I get 0.796, which is answer A. Okay, question 7. We've got an integral question because we're looking at determining the function given the derivative. So we're given the derivative, so we actually want to work out what is the function, and that's going to be the integral of 6x squared plus x to the negative 2 plus 1 over x dx. Integrate that, add 1 to the power, divide by, so it's going to be 3 divided by 3, 6 divided by 3 is going to be 2x cubed plus, this is going to be add 1 to the power, so it's going to be x to the negative 2 over, negative 1, it should be, over negative 1, plus ln x plus c, don't forget the plus c. Now, they give me some more information, and that is when x is 1, f of x is 5, so 5 should equal 2. Now, 1 cubed is just going to be 1, so 2 times 1 is 1. This is going to be minus 1 over 1, which is just 1, plus ln of 1 plus c. Hopefully, you know ln 1 is going to give me 0, so I've got 2 minus 1, which is 1, 5 take away 1, that's going to give me 4. On this side, c is 4, so I get, I don't need to write the full function out, you can see there that it is answer B. Okay, question 8, the displacement of meters of a particle is given by s of t equals negative 3 cos t plus 2 sin t, where t is in seconds. The instantaneous velocity, so velocity, we're going to have derivative of the displacement function. So there's the derivative of the displacement function. I've worked that out. 3 sine t minus 2 cos t. Now, when t is equal to pi on 2, I'm going to get 3 sine pi on 2 minus 2 cos pi on 2. So that's going to be 3 times 1, which is just 3, minus 2 cos pi on 2 is 0, so that's going to be 0. So that's just going to give me 3. I could have used my calculator to do this, using the calculator feature of the derivative, but I think by the time it took me to sort of type that into the calculator, I think doing this by hand is a little bit quicker. So the answer is D. And question 9 is definitely easier to do using your calculator. You've got f of x equals 2 to the power of 2e to the x plus 5. G of x is 3 over e to the x. The intersection point, using my calculator, if I type those two functions into y1 and y2, and then I sketch them, I can determine that the intersection is given there, negative 0.693 and 6. So the answer is D for question 9. And last question, we've got question 10. A object travels in a straight line so that its velocity at time t seconds is given by v of t equals 2t plus sine 2t. Determine the expression for the acceleration as a function of time. So you need to realize that acceleration is going to be your derivative of your velocity. Now you're given the velocity function, so you should be able to work out that. If I work out the derivative of that, so 2t just becomes 2 plus cosine of, is it 2? Yeah, 2t, and then we've got to multiply that by 2. That is, I can already see that that's answer A. So that is the 2021 QCAA Maths Methods External Assessment Paper 2.